So now we get to do the last part of 8.5, which is going to be factor by grouping. So what's going to happen is they're going to give you something that has 4 parts, but nothing's going to be able to come out of all 4 of them evenly. So for example, 4, 7, 28, and 49, there's not one number that divides evenly into all of them. I mean, besides 1, but that doesn't do us any good. Likewise, 3x's, 2x's, 1x, no x. I can't take an x out either. So this is where I'm going to factor by grouping the first 2 terms together and the last 2 terms together using parentheses. And then I can factor each individual parenthesis separately. So first I look at the parentheses on the left. 4, 7, no, I can't take anything out of that, but I can take x cubed, x squared. How about an x squared out? So that gives me 4x plus 7. That part right there is exactly what we've done the last 2 days. Now do it to the second parentheses. But this time I think I can take a number out. How about a 7? Actually, how about a negative 7? And that's going to give me a positive 4x plus 7. Wow, and if you notice, something really cool happened. These parentheses are the exact same. So this is going to end up being really, really fancy combining the like terms. Let me give you a side example over here. If I had given you, I don't know, something like 2x plus 3x, you would tell me that that equals 5x. And the way you got that was by adding the 2 plus the 3 to get that 5 to the x. Or the 5 times the x. So what if I made it fancier, like terms, and made it like 2 parentheses x, and then a 2. Oh, sorry guys, that's not what I wanted to do. Let me try again. If I made it like 2 parentheses x plus 1 plus 3 x plus 1s. Well, these are still the exact same. It's just that they're really fancy like terms this time. So this one would be 5 of the x plus 1s. And again, the way you got that was by taking the 2 plus the 3 for the x plus 1s. If you notice, this is starting to look familiar, like what I have over here. It's just that over here, I have a fancy x squared and a minus 7 instead of a 2 and a 3. So if I am combining like terms over here, that's going to be x squared minus 7 4x plus 7. And again, all it is really, really fancy combining the like terms. I always get this question, Miss Barnum, what happened to the second 4x plus 7? Well, let me counter by asking you this. What happened to the second x right there? Or the second x plus 1 here? When you combine like terms, you're only having to write it once. So this is my final answer right here. I do want to do another one. Let me get that set up real quick. So I have a second one ready to go. And again, I start by asking myself, is there something that can come out of all four of them? And unfortunately, the answer is no. But I can try factor by grouping. So I use a bunch of parentheses again, and I say, okay, what can I take out of the first parentheses? And it looks like I can take out a 9 and an x. So that leaves me with x squared plus 4. Oh, you know what? I could have taken 2 x's out, huh? So that's actually going to leave me with x plus 4, nice and even like that. Now, when I look at the second set of parentheses, my initial thought is there's nothing that can come out of there. But if I'm looking ahead and trying to potentially combine like terms, I can see that these are not going to be the same. In fact, all the negatives are flipped. So what I'm going to try doing is I'm going to try taking out a -1. And that's going to leave me with a positive x and a positive 4. And now my parentheses are the same so that I can do my really fancy combining of like terms. So 9x squared minus 1 and x plus 4. Hey, by the way, if you wanted to know if you were getting these correct, there's an easy way to figure that out. FOIL, that 4-letter F word, do that. So like 9x squared times x would be 9x cubed. 9x squared times 4 would be 36x squared. -1 times x would be -x. And -1 times 4 would be -4, which it turns out is exactly where I started. Hey, these ones are weird, and I get that. Watch the help video on Delta Math, and let me know if you have any questions.